In this video for section 3.3, we're going to talk about something called the empirical rule. The empirical rule describes a bell-shaped distribution, which looks like a bell. We also will later learn that this is called the normal curve. In a bell-shaped distribution, about 68% of the values fall within one standard deviation of the mean. What that means is that if I have the mean marked here with the red line, and I add a standard deviation, that's represented by this dotted line. If I subtract a standard deviation, that's marked by this dotted line, 68% of the values will fall between those two dotted lines. 95% of the values will fall within two standard deviations of the mean. So this is mean plus 2 times the standard deviation, and this is mean minus 2 times the standard deviation. And virtually all, or about 99.7% of the values, will fall within 3 standard deviations of the mean. So we're going to look at this example with Eddie's Burgers. They have the number of chili burgers sold each day for the past 365 days. And they want to know if the data seem to come from a bell-shaped population. So I have this data Minitab worksheet posted in Blackboard so that you can open it. The first thing that I did was I calculated the mean and standard deviation using display descriptive statistics. We've already seen how to do that. And the descriptive statistics that I'm displaying are in column 2, which is the number of chili burgers sold on each particular day. Column 1 is just keeping track of the day number. What I also have done is I've done a tally chart, this is a frequency distribution. Remember, to get this, you go to Stat, go down to Tables, and tally individual variables. And we're going to see how this is useful in just a minute. So I'm going to copy this over just to make it a little bit easier to refer back to here. So what I need to do is I need to figure out where these dotted lines are, and then I'm going to figure out using the tally chart if 68% fall within these dotted lines. Then I repeat the process for the 95% and 100%. So what I need to do first is I need to use my mean and standard deviation to calculate what mean plus standard deviation and mean minus standard deviation are. So mu minus sigma, remember mu is mean, sigma is standard deviation. I'm going to round these to tenths just to make the calculations a little bit easier. So 15.1 minus 3.1 is 12, and then mu plus the standard deviation is 15.1 plus 3.1, which is 18.2. So the question is, what percent of the data in my table fall between 12 and 18.2? So going back up here, I have 12 here, and 18.2 would be including 18 but not including 19. So if I add these numbers, 31 plus 39 plus 34 plus 47 plus 38 plus 43 plus 31, I would get 263. You can add those using a calculator if you want to. So 263, and 263 divided by the total number of days in my table, which is 365, that is 72%. So remember, what I want to know is if that is close to the 68%. Now, obviously, it's not exactly 68%. Is it close enough? I would say yes. If it's within 5%, that's probably close enough. So it doesn't have to be exactly that percentage, but close enough. So now I need to repeat that process with the mean minus 2 standard deviations and the mean plus 2 standard deviations. I'm going to switch to a different color here so you can see what I'm doing. So mean minus 2 sigma is 15.1 minus 2 times 3.1. Do this on a calculator if you need to. I'm not showing the calculator, but obviously you can do that. That's 8.9. And mean plus 2 standard deviations is 15.1 plus 2 times 3.1, which is 21.3. So what percent of the data are between 8.9 and 21.3? We're looking to see if it's about 95%. So going back up to my table here, 8.9, that would include these at 9, but not the ones at 8. And then going down to 21.3. So that would include 21, but not include 22. So 9 all the way down to 21. So add up all of the numbers in that purple area. Now, an easier way to do this is going to be just to add the ones that are not in that area and subtract it from 365. So I have 5 here that are outside. I have 6 here that are outside. That's 11. 365 minus 11 is 354. So that's 354 divided by 365. Divide that on your calculator, and you get 97%. So is that close to 95%? It's pretty close. So I'm going to say that that one is good. And finally, we need to check 3 standard deviations. So what I need to do first is calculate my endpoints. So switch to a different color here. I need mean minus 3 sigma, so 15.1 minus 3 times 3.1, and that is 5.8. And mean mu plus 3 sigma is 15.1 plus 3 times 3.1. Again, do these on a calculator, that's 24.4. So our question now is how much of the data falls between 5.8 and 24.4? Well, if I go back up and look, I don't have anything less than 5.8 because my smallest number is 7. I don't have anything greater than 24.4 because my greatest number is 24. So that means all of the data, 100% of the data, is within 3 standard deviations of the mean. And so that is checked. That one is good. And since all 3 of them are good, that means that we can answer our question here. Do the data seem to come from a bell-shaped population? With yes, they do seem to come from a bell-shaped population because all 3 of those percentages match up. So a little bit of a long problem here. But that's the process that we go through to figure out whether a data set seems to come from a bell-shaped population.